But anyway, I'd now like to introduce Des Watkins. And Des is going to talk to us about fabrication and some clever stuff that he's done, and turning digital into real stuff, so a practical story.
I have been to a number of different conferences, seminars, and they always try and shock you with data. And one of the data was, within so many years, 80% of the businesses in this room aren't going to survive. You're either going to be bought out or merged or folded, or we're just going to transform completely. And I thought to myself, well, Watkins Steel, hopefully we'll be bought out, but I can't see that happening. Nobody will want to merge with us. Folding? Shit, I hope not. And transforming. We've been going for 52 years. My father started the company in 1968. Transforming, steel fabrication by its very nature is just one step away from being a blacksmith. You cut steel, you weld steel. You can't really transform it much at all. But that's what I thought. But it was back in 2012, a dark period for Watkins Steel. We weren't going that well. A management team meeting, we really had to do some soul searching. What can we do differently? And through necessity, we came up with what we developed, our 4-step process: laser scanning, technical software, advanced robotics, total station. How it started, though, was a study trip around Europe where we started looking at the impact that automation and robotics had in the steel factories in Europe. So we invested in our first line of robotics, November 2014, the Vortman V808, a 3-dimensional robotic plasma that transformed our business. But it was only as good as the information we were feeding it, which meant we had to upgrade technical software. Because a lot of what we do is what we call brownfield sites, refurbishing and modifying existing structures, is only as good as the information we're getting from site, which led us to total station laser scanning. So when we had the steel fabrication right, it was only as good as putting it out on site, which then led us to the total station. So, as an example of what laser scanning is and the 4-step process, is anybody familiar with laser scanning? Has anybody used it before? So you'd be very familiar with it. So a laser scanner shoots 1 million dot points a second in every direction. As long as there's a 30% overlap from one scan to another, configures, triangulates, and gives you a 3D image. So that 3D image is made up of billions of dot points. But the beauty of it is, by pairing it to technical software, you can now detail in a point cloud without dimensions. Technical software operates the robotics. So the steel gets processed to suit what's on site. And then, before you even take the steel to site, a total station will tell you where to drill every hole without the string line, chalk line, tape measure, anything. The beauty with this, and you might just pick it up here, is the builder put his holes in the wrong spot. Now, when you ring up a builder and say, hey, mate, your footing's in the wrong spot, they'll always reply, bullshit. When you send them a screenshot, in this particular situation, it was a case of, hey, bugger me, can I come have a look at this? We say, mate, look, your hole's in the wrong spot. Yeah, no, don't worry about that, I'll fix that. Hey, all my timber's too long there. Can you tell me how much timber I need for that top deck? So all of a sudden we realised we're turning into a project manager. The beauty with technical software, though, is it goes across any trade. So if you detail the glass, the timber, any building material, it'll program any CNC machine without the need for human input. In this particular situation, we call it a treehouse, actually a granny flat. By detailing the timber, we gave the USB to the builder who had all this timber pre-cut without the need to measure anything. Because then a trade isn't reliant on the previous trade, and if all trades were working from the same model, you can take weeks or even months out of any program. One of the reasons why we're actually specified to do this job was by putting the architectural Revit model into the point cloud, we could tell the builder what branches needed to be cut before they even started on site. The issue or the problem you have, though, is when it comes to building or construction, you can't wait for something to be built before you scan it, detail it, fabricate it, and install it. In this situation, we had to do the steel in the roof. So we fabricated our steel off the architects and engineers' drawings, but the day before we were due to turn up on site, we went out there and scanned it, overlaid our model, and this is what we found. In the top left, the block layer didn't put a notch out in the wall for us. Top right, they didn't cut the wall down to the wrong angle. The bottom picture, the wall's off grid. Walls were too high, walls were too low. Now, if anybody's had any experience with block layers, you know this is pretty well par for the course. But traditionally, if we turned up on site, the builder would have said, did you measure it right? Did you fabricate it right? Are you installing it right? I've got a tower crane here I'm going to have to back charge you for. Fix it and get it done. But now by sending these screenshots, it's a case of, hey, what do you want us to do? And it is so much easier and quicker fixing steel in a factory rather than on site. But we estimate that this would have taken 2 men a week on site modifying our steel to fix it, even though it wasn't our problem. The issue that nobody would have seen happen, though, by modifying the steel to suit something that wasn't right, in a month's time, when the gutters had to be put at different angles of the roof, it would have come back to us. So it's going to cost us a lot more money than just modifying the steel. Another area that we've used laser scanning, and we initially bought laser scanners just for site measurements, but now we can use them for tender submission work. I don't know if anybody recognises the Commonwealth Games, the Arbour, that was held at the Gold Coast just recently. But we had 9 people come to Watkins Steel. We had representatives from the Queensland Government, the Commonwealth Games Board, the builder, Grocon, JMAC, BMD. They came to see if we were able or capable of doing this job. So we laser scanned the actual site, got the architect's Revit model, imported it into the scan, and then we pointed out to them it wasn't going to fit. Under the breath of 2 of them, I heard them say, bugger me, look at this. I knew we had the job. What they got us to do was install the structure, leave a section out, then give them a quote to come back and fix it, to finish it when the scaffold came down. It was a $15,000 variation. If we won the job, that just would have cost us if we didn't know that it was going to clash. But where we get our true value is when it comes to scanning over multiple times during a project. It didn't matter whether they put their holding down bolts in too high, too low, twisted, or off grid. You scan what's on site, which programs the robotics so you know it's going to fit. Now, it gets to the stage where I used to drive around with cardboard in the back of the car to do templates. Even for really small jobs, this is a bit of reverse engineering for a digger where they wanted to put a guard on the front. You can show them what it's going to look like. They can see the view that they're going to see through. But the beauty of it is, by now having a soft copy, if it gets damaged or for another vehicle, they can replicate it, can go straight to a plasma or any sort of machine, and they can fabricate it to suit. Even if they don't have any CNC machines, Tekla software will generate a hard copy so they can replicate it, complete with dimensions. So from continually trying to push the boundary and find out where things are going, led us into augmented reality. And from this, we used the Microsoft HoloLens. And just one application we tried using it for is fabrication. So it's augmented reality, fabricating steelwork without the needs of drawings, without the needs of doing a layout. In this situation, it's just what you can see on the background, but a really simple handrail panel to weld in the balusters without the need of a tape or drawings or measurements or anything. The beauty of this is what you're actually looking at through the HoloLens, you can also see at the same time in your office or another country, wherever, on the computer. So fabrication is one application that we're using the HoloLens for. Still in its development stage, the accuracy is not that good. The second version's due out any day now, and we believe it's going to be a lot more user-friendly. Another application that we're using augmented reality for is quality assurance, or even trial fitting things on site. This is a spiral staircase. Always a bugger to try and check measure because you've never got 2 straight surfaces. But by overlaying the model to what we fabricated, making sure it was pretty close, what we could do then is just take the HoloLens to site, trial fit the spiral staircase. When we did this, what we realised was it's going to hit an air conditioning unit, and we had to cut away a bit of timber reveal. So we could get it modified before we actually took the steelwork to site. But the true value that we get using augmented reality is the confirmation of a design. This is a bottling plant, Coca-Cola bottling plant. By taking the factory manager through the design, he could actually see what was proposed, the walkways, the gantries, the access ladders. And as he was walking through the factory, he was saying, I want 2 more bollards here. Can you move that ladder this way? But what he was seeing, we were seeing in our office, and we were taking notes and making the changes to suit. So that way, he confirmed it. The next step, obviously, is getting the Revit model of the bottling plant itself, putting that in the model so you can see a working model. You do lose a little bit of resolution. The HoloLens is like just a fancy pair of Windows 10, so this is just a video just showing what he's actually looking at. But it's a lot crisper when you see it on a computer, and a lot crisper through the actual HoloLens itself. From AR, we branched then into VR, virtual reality. Now, everybody's used, or most people have used virtual reality for killing dragons and shooting people and doing whatever. But to use it for a practical application in a trade situation, we're trying something a little bit different where we're using it for tender submission work. In this particular situation, it's a shopping centre. We got the architects and engineers' drawings looking at the proposed steelwork. We modelled the steelwork, imported it into AR, and by doing this, what you can actually see is what it's going to look like, if it's going to fit. Rather than letting them walk through it, we made it static, so you go from scan point to scan point. And by putting the point cloud into VR, you can now accurately measure plus or minus 2 mil over a 65 metre distance from your office. What you'll see here is clash detection, where we pointed out that that light pole was going to get in the way of that awning frame. Something we wouldn't have been able to do traditionally as the way you traditionally quote a job. What I love about VR is we've now got a shared platform called Cintu that anybody can view this on their computer, and the size of the file is a lot smaller, so you don't have that problem of downloading a point cloud. By pairing VR headsets together, you can have multiple people walk through the same site. And if I was in the site with somebody else, you'd have Des written above me, you'd have a line to see where I'm looking at. But every time you scan the site, it updates VR. So you can do site visits now without going to site. You could do site visits with multiple trades, all in their different offices, without anybody having to be on site. One of the reasons we made it static, and the step that we're taking this forward with, is to try and incorporate animation within VR. So by saying, okay, go to scan point number 3, this is where we believe you should do the deliveries, and show the truck drive up into deliveries. Go to scan point number 5, this is where we believe you should put the hoarding. Click a button and show the hoarding getting put up. But the next step that we want to work on is the sequential construction process in animation linked to a program to show them the time frame of something getting built. If we got really fancy, try and put that to a budget, so then you can compare it on a week-by-week or time-based when the program is actually getting done. And that's enough of that one. So putting it together, a food processing plant wanted to put in some new equipment. So they just gave us the 2D drawings of the new equipment they wanted to install. So the paper plans they gave us, we created a Tekla model of that equipment. We imported the model to the HoloLens so we could take it to site, show them what it was going to look like and where they thought it was best going to be positioned. So by doing that, they could move it around, they could lock it in position, then walk around it. When they're looking through it themselves, wearing the HoloLens, they paired it to their head office. Their head office viewed in and was watching what they were looking at, and they were talking to each other. Then by pairing that with a point cloud and locating the model where they want it to go, you can now accurately modify the existing site so that when the equipment does turn up, there's no modifications required for it to fit. You've already done it. So it was done over a weekend. Very quick, minimal downtime. what I love about this one, and what I wanted to show you this one for, once a month, we're contracted to do a volumetric report for a pile of sand on the Brisbane River to see how much sand they use. It's got nothing to do with steel. So Watkins Steel, now we've created this other company called HoloVision. So HoloVision's in charge of our IT. HoloVision does our scanning and HoloVision does our drafting. HoloVision's growing faster than Watkins Steel. So really simple, a pile of sand, they were getting a surveyor there that was climbing all over it with the staff, getting a volumetric report. Now, after a couple of scans that morning, we'll give them a volumetric report, that pile of sand, 1,548.34 cubic metres. The next step after that, of course, and now being HoloVision, which is completely separate now from Watkins Steel, we started getting into drones. Now, a lot of people use drones. We've tried using it a little bit differently. We linked the photogrammetry of our drones to the point cloud of our laser scan so you can get accurate measurements. Once again, nothing to do with steel. We're now contracted by some properties out west to fly the drone over, do levelling and contour maps, and work out things like the negative volumetric reports for their dams, how much more water can the dam take, channel country, where water's going to stream. A lot of the technology that we've tried using, when we've started it, we had no idea where it was going to go. But what we have found is with the drone, apart from giving the farmers contour maps, where with the levelling reports, you can now give them a percentage of tree coverage. In Queensland, a real issue with clearing land. So if you do it over a period of time, you can tell them how much tree coverage you've got, if any trees have been removed, area for the dam, contour maps, and then there's 13,613.2 cubic metres of water that can still go in that dam before it overflows. How one leads to the other. A school in Brisbane, Ascot State School, had to put in a disabled lift and do more access. So the principal actually saw what we were doing, saw us scanning it, and said, hey, I'd love you to do a scan of our garden that we're doing, and the kids are putting this new sculpture. They contracted us to do this, separate from Watkins Steel. Realising we had the drone, can we also get you to come out and fly a drone over our oval, because our kid's going to spell out 100 to celebrate our 100-year anniversary. Once again, nothing to do with Watkins Steel, but all of a sudden there's this new business that we're now flying drones and doing photographs for schools. But just an example, linking it to the point cloud, you can now accurately measure. If you scanned in the building as well as outside, you can do fly-throughs where you traditionally couldn't get a drone to go. Just how things go differently. Has any steel fabricators, has anybody used ceramic tags or kettle tags? Barcoding of steel. Kettle tag can go through a galvanising bath 500 degrees Celsius. It doesn't actually affect the barcode, or you can still read it. We traditionally did it just to track where the steel goes, so for logistics. But anybody that was in the workshop yesterday saw, by modifying that barcode, you can now scan it with your mobile phone and pull it up in your phone, change it to augmented reality, place it over the object and check it. How many people were in the workshop yesterday? So you know I'm not lying. To give you an example of how to use it, and if anybody's got a phone, you might even be able to view that from your phone where you're sitting. It just shows you what it can do, or how to do it. So barcodes aren't new. QR codes aren't new. They're used quite often. People use them to pull up information. But this is just a little bit of a different application on how to use QR codes for a practical application that would help steel fabrication. The example that's shown there in the video, it's a 3-storey walk-up. So now you can place that 3-storey walk-up on site, see if it's going to fit. Where the guys have taken this, and this is what I love, is how fast things seem to be moving. Now there's even an app on your phone, whether it be, it's got to be above an iPhone X, but with the front-facing camera that gives depth, you can now scan any object, create a QR code for that, and import it into the environment, which the guys at Watkins Steel or HoloVision created on Monday this week. So I love how fast things are moving. The future opportunities, or I call them wacky ideas. They talk about the mobile phone being the death of creativity. You're waiting at a bus stop, you're waiting at a doctor's surgery, you're on your phone. I love sitting on a plane now where I don't watch the movies, I don't get out my phone, but you think of some absolutely crazy ideas, and I just love calling them the wacky ideas. As long as you have a notepad and pen, start writing them down. But drones linked to new technologies. The idea that I'm putting to the team is we've got our drone, we've linked our drone, or the photogrammetry of our drone, to the point cloud of a laser scan, which gives you your XYZ axis or geospatial awareness. Because we've now got Tekla software in the link to the scan, Tekla software has got the macros that can operate machinery. You've got your welding arms, your automatic welding arms where you can turn on and they weld. So what's stopping you from linking that welding arm to a drone? Don't think of a drone as being airborne, but think of it on wheels or magnet or air. All of a sudden, you've got a working droid. The importance with all of these wacky ideas is not that they come to fruition, but it gives the team something to work with that they might say, hey, I couldn't do that, but I did this instead. And they've come up with some really just humdinger ideas. Robotic welding. There's a lot of robotic welding that's out there at the moment. We're looking at getting our inline robotic welding in about 2 years' time. The hardware is fine now, it's the software they're still working on. But the robotic, what we're trying to do is incorporate robotics through Watkins Steel, doing all different things. We believe that with our business modelling showing that with the robotic welders, it'll increase, we'll need an additional 25 people to cater for the workflow that's going to generate. Holograms, teleporting avatars, we're doing that now. In terms of whether it be AR or VR, but pulling different people into a model that it might even be, instead of Watkins Steel, it might be Watkins virtual meetings. And as smart as what I'd like to think all our young guys are, and there's a joke that I say with them, they still don't Photoshop me with hair in any of those avatars. Animation within augmented reality and virtual reality. The issue with this has always been the size of the files, they're too big, which they're now working on reducing the size of images. But when it comes to actually showing that sequential construction process within a program, or within VR, within AR, it's going to just show people exactly how something's going to go. Other forms of smart glasses, there's a heap out there. The Magic Leap, the Vuzix, the Realworks, they've all got a slightly different application. But what we're finding is, just by mucking around with them and playing with them, we'll find specific application to us. And linking technology to create and deliver new customer value, especially with Tekla software being the main glue that holds it all together. But I've got an example of that later. But by trying to get the guys, or by getting the young lads at HoloVision, just whatever equipment they need to muck around with or play with it, they're coming up with some brilliant ideas. An example about what I was talking about, the power required for some of these images. Any 3D image that you're creating is made up of a series of flat surfaces. Now, I think it's the one on the right is made up of 70,000 surfaces. They've modified the software, modified the algorithm, whatever it is. And the one on the left is made up of 7,000 surfaces. So they've reduced the computational power required down to 10%. Why? I don't know. It's great that they've done it, but it turns out now that that's required for what they want to need to do for animation. And I think what I love is, as a business owner, it's that leap of faith, letting them play with it, letting them muck around with it, and pretending I understand it. Engineers might recognise this software, Statica. It's like, and I don't want to pretend I'm an engineer, but it's engineering for dummies. By colour coding the stress analysis of a connection will tell you whether it's going to work, whether it's going to fail. So if you apply Statica to a connection and apply the loads required, red means it's going to fail, blue means it's safe, and then you can just change the size of the plate. Okay, let's change the size of the plate, the welds, the holes, the steel, and by getting rid of the red, the orange, you can design it to the safety factor that's required. Now, there's software out there called Edgewise software. Edgewise, once you load into it a steel library, it'll identify a steel object. So if you've detailed something in Tekla and you apply Edgewise, you could go into a factory with augmented reality, turn it on, it would identify and recognise the steel, load Statica in it, and it'll actually show you the weak connections. We haven't done it, but once again, just trying to set that target for the young lads to work on. They may not do it, they might come up with something else, but I love where they're taking it. So with this whole journey of Watkins Steel and HoloVision and where it's going, look, I've loved the journey. I've loved where it's gone and a few learnings along the way. And some of these have really made me think differently. This first one, every now and again you have to work for a real prick to appreciate the good ones. And you can, for this one, you can change it. You could say you need to employ a real prick to appreciate the good ones. You need a real prick of a supplier. But it's really made me appreciate the good people we work with. It's really made me appreciate the staff. I'm lucky to be where I am. If you're the smartest person in your company, employ smarter people. The good thing about this one is I've got no fear of this one at Watkins Steel. There's a lot more people there smarter than me. Invest in your staff. This was a major mind shift for me. But it just goes to show the more I invest in the staff, the bigger the return. HoloVision, predominantly a younger cohort, once a month they have a forum. And one of the forum items is if they can find a conference, a course, a symposium, a seminar, book club, book launch, whatever, anywhere in the world, they go to it. They haven't found anything in Brisbane. They haven't found anything at the Gold Coast or Sunshine Coast. They haven't even found anything in New Zealand. But they found some really cool stuff in Las Vegas, in Europe, in Germany. And to be fair, go to it. When they come back, they do a download and just tell us what they've found out. But once again, going back to that number one, appreciating the good staff. I sent, October just last year, I sent two staff members. Brendan, who's our senior drafter, and Jacob, a young junior, to Autodesk Uni. Brendan came and saw me and goes, hey Des, I wouldn't mind getting over there a bit earlier. I'd love to see a game of NFL and I'd love to see a game of basketball. I said, mate, that's fine, you go. Jacob came to see me. He goes, hey Des, I wouldn't mind getting over there a bit earlier. Just get over jet lag. Good on you, Jacob. Away you go. When people come through Watkins Steel, I show people what they're working on. I went over to young Jacob and I said, oh, this young Jacob just came back from Autodesk Uni. Jacob, what was the best thing about your trip? Oh, the basketball, definitely the basketball. No. I mean, Jacob, what was the best thing about Autodesk Uni? They took us to golf one night. That was really cool. So in one way, I congratulate him and applaud his honesty. On the other hand, I've got to just teach him how to lie a bit better. Robotics and automation creates jobs. It doesn't replace jobs. Our first line of robotics was November 2014, and we're up to our fourth line of robotics now. But every time we've put a line in, we've employed an additional 10 people. And as I said before, with the robotic welders, our business modelling shows that we'll be employing an additional 25 people. The good thing about the robotics is it's bringing your man-hours per tonne down. By bringing the man-hours per tonne down, you're becoming more and more competitive with the overseas market. And right now in Australia, there's over 600,000 tonnes that gets imported every year. So by becoming competitive with that, you can pick and choose as much work as you want. Team up. Look, a really important one. Traditionally, I don't know what the steel industry is like in New Zealand, but Southeast Queensland, competitive, super secret, nobody really collaborated with other people. But what I have found is the more we've reached out, the more we've talked to different people, the more you get in return. We've teamed up with different levels of government, we've teamed up with different educational institutions, we've teamed up with other fabricators, suppliers, and what we found is the more we team up, the better we go. Collaborating. Steve from the University of Wollongong, I was lucky enough to be invited down there, and it just changes the way you think. They all have a different perspective, but you're continually learning from teaming up with different people. Surprise and delight. And this is one that I love. The young kids, and I'm 50 years of age, so you can call them kids now. The young kids at Watkins Steel, their position description is to surprise and delight. We buy them whatever hardware they want, whatever software they want, and they'll come up with some really special stuff. But the real secret to it is that you've got these young kids that have got all the theoretical ability and all the knowledge, but you mix them with the old crusty Boilermakers in the factory that have got all the practical ability, and that's where the magic happens. They're solving problems that they wouldn't have thought were problems. So it's all about that, teaming them up, with the staff, your own internal staff, and it's really changed where Watkins Steel is and where we're going. Look, that's the true message I want to get across today. There's a couple of things. One is I applaud Hero, a terrific organisation. And by watching what you do, it's incredible. I think that every steel fabricator would benefit by being a member. A couple of things I got out of this morning, but one was I loved about that, if you live by the sword, you're going to get shot by somebody with a gun. I thought that was brilliant. Which reminds me about you can't lead a horse to water, but you can salt his oats and make him thirsty. So it's a different way of thinking. And another way, just a different way of looking at things, but things have never moved as fast as what they are now. But if that's the case, right now is the slowest they're ever going to move going forward. So it's going to be a great ride we're going to be part of. Hey, thank you very much for the opportunity to talk. Look, I love what I do. It's from where Watkins Steel was to where we are now. I'm on the journey and I can't wait. I'm really looking forward to seeing where things go. And even this week, how fast things have changed for us at Watkins Steel. And it's really exciting to see where things are going to go in the future.